Hi everyone and welcome to this video. Today we're working through a classic IB Math AAHO optimization problem involving trigonometry and differentiation. We're going to be solving question 11 from the May 2023 Paper 1 exam. If you haven't tried this question yet, pause the video now and give it a go before watching the full explanation. Throughout the explanation, the points awarded by the mark scheme will be displayed in yellow at the appropriate section where they would be awarded. Alright, let's begin. But before diving into question A, let's break down the question. First, let's look at the situation you're given. Points A and B are set to be variable, but at the same time, A, B, and C are collinear. This just means the points aren't completely free, but rather if one moves, the other must respond, with the length of the blue line being the given L. The constraint on alpha is also limited by the conditions. They're being nice by spelling them out for you. Alright, on to question A. Notice that we can create right angles by projecting A and B to their opposite wall respectively. This naturally generates two triangles CAA' and BCB', so we can break down L into two distinct lengths, length of A and length of B. We have two parallel lines crossed by the transversal AB, a classic configuration, and so CAA' and BCB' are similar. This implies the angle at A is also alpha. After that, we use standard right angle trigonometry to find both length of A and length of B. This yields one accuracy point for each. L is just the sum of both, and we get the given answer. Now moving on to part B1, we have a trigonometric derivative which is solved as shown. For part B2, we equate our expression to 0 and proceed from there. It's not necessary, but changing to the familiar trig ratios gets rid of some of the mystique that trips some people up. As a matter of fact, the mark scheme gives an implied method mark for the attempt and an accuracy mark for the correct expressions. We now have fractions, which we can get rid of by multiplying cleverly. Notice the answer given has arctangent, which means that it's reasonable to try to find only tangents in the equation. This is why we don't multiply by cosine alpha. We leave it there since sine over cosine gives tangent. After that, we have a cubic equation with only tangent, which we solve as shown to get the given expression. Alright, next question. We start with the second derivative for part C1. Given the expression we have for the first derivative, this may seem a bit daunting. However, derivatives are like a puzzle. You can take it by steps, solve them separately, and put it all back together in the end. Let's see this in action. We start by using linearity to break down the derivative into two simpler ones. Let's focus on the left one and forget everything else. We have a product of two functions, so it makes sense to use the product rule, the attempt of which awards one implied method mark even in just this one piece. You could collect like terms and stop. The mark scheme would award one accuracy mark once you multiply by the coefficient we left behind, but recall that it's extremely common to solve the derivative equals to 0, so it's a good reflex to factorize your derivatives. After that, some cleanup using trig formula from the booklet gives us a nice expression. Let's put this on the side, ready to be used but not getting on the way of the other one. The manipulations are very similar as you can see. We put this on the side too. Going back to the expression we had after the very first step, we can see where to fit in the pieces we just got. In our method, this is where we would be awarded the accuracy marks. After cleaning up the double minus, we get the final result. Note that this is not unique. Your answer may look different. As long as they are equivalent, they would both be fine. Then for part C2, we replace arctangent 2 into our expression, noting that we can already simplify any tangents and cotangents present by the definition of arctangent. After that, we have to deal with stuff like the secant of the arctangent of 2, which seems complicated, but what we used just before gives us the tactic. we need tangents or cotangents to get rid of the arctangent. A quick look at the formula booklet will let you find such formula. Solving for secant and cosecant, respectively, we can cancel all trig expressions as shown. We get a method mark for the idea and an accuracy mark for the correct values. Putting it all together gives the last 2 accuracy marks before the given answer. Alright, moving on to question D. The justification of part D1 just requires us to make quick deductions of what we know is true when the angle is arctangent 2. The first derivative is 0, which means we have a stationary point. The second derivative is positive, so the graph is concave up. So L has a minimum at alpha equals arctan 2, the explanation itself giving the one reasoning mark. For part D2, we replace arctangent 2 into the expression for L. The cancellations follow the same logic we used on part C2. Writing the expression gives one implied accuracy mark, while the simplification gives the next one. Finally, for question E, we can see the minimum length illustrated at arctangent 2 back on the initial setup. With a pole of given length, the best we can try is to put it next to the wall and rotate, but this is stopped by the wall on the other side. Mathematically speaking, the minimum length we found gives the boundary of what could or could not go through. Stating something equivalent or showing the inequality gives the reasoning mark. Finally, just don't forget to write a conclusion to get the accuracy mark. And boom, there it is. We got all 19 marks. The main points of concern for this question would be to understand the situation, not let the reciprocal trig ratios scare you too much, and handle the derivatives piece by piece. Alright, that's it for today's video. Feel free to request any specific question in any IB math paper in any year if you wish to see a detailed explanation. This video is brought to you by Lighthouse Global, your personal online tutoring for IB, college applications, and school subjects.